In this guide, we will learn how to set up our local workstation to run and test challenges. We will fix a security bug, locally test it, and push out changes to get a score for a challenge. We can run the challenges either in a container in our workstation or on the host. And by the host, I mean the operating system that we are using, Linux, OS X, or Windows. With regards to the Windows, firstly, we need to install an Ubuntu desktop virtual machine or any other Linux distribution that you are familiar with in any hypervisor, in this case, VirtualBox, and then you can follow along the commands that I run as part of this guide. For OS X and Linux, you can simply follow along the things that I'm going to go through. By running the challenges inside the container, all the required app dependencies are automatically given inside the container, so you do not need to reinstall them. If you decide to run the challenge on your host without the container, you just need to manually install those dependencies, and those dependencies, depending on a programming language that is being used, are also given in that source code repository. Now, firstly, I'm going to going through running this challenge using a container. Head to Python game and select setup.py. If you scroll down a bit, you will be seeing a bash script or a bash command that is being given to you. To run the challenges locally, we need firstly to add a SSH public key to our SecDim account. And we also need 3 commands: git, make, and docker. Git and make has been already provided or given by default in the majority of the Linux distribution and OS X. The only thing that we need to install is docker. Now, this bash script will effectively go through all this process, including adding an SSH key to your account. So copy this command, open up a terminal, paste, and execute it. Firstly, it will ask if you have registered an account on SecDim. If not, well, just simply hit sign in button here, go through the registration process. Secondly, have you added your SSH public key? During the registration process, it will ask you if you have already to provide your SSH publicly. If you have already done it, so you just enter no, otherwise enter yes, otherwise no. If you have signed in using GitHub and GitLab, you need to manually add your SSH public key, and to do so, you can simply go to your account settings, and this is universal across any way that you have logged into your SecDim, and head to SSH key, add or update SSH key, and these are the basic instructions to follow to add your public key. Otherwise, this bash script will do all that for you. No. The next thing this script does, it will generate a default pair of SSH keys, and it will copy the public SSH key. If this has been already generated on your system, it will reuse it, and then it will ask you for your username and password for SecDim account. It will then add that SSH key to your account. It will test if the SSH connection can work. And if all good, it will goes to the final stage, and that is installing the tools that is required. You can run this bash script as many as you like, and you can go through them. Even if you have these tools already installed, git, make, and docker, this script will first check them before trying to installing them. And in this case, since I have already these tools installed, it quickly finished, and now my workstation is ready to start a challenge. Let's head back to the challenge, scroll to the top, hit play to grab the SSH URL. Either you can hit copy here, or you can click on any of these buttons to automatically open your IDE with this SSH URL, with this git URL, or you can hit clone to get the same pop-out out. Copy that, head to the terminal, git clone, paste, and you will be given a local copy of this this repository. Now I have a local copy. I can use my IDE. In this case, I have Visual Studio Code to open this up. And as you can remember, these files that I have already here have been also given to me on my local system. Now, a few simple commands to remember. You open a new terminal. To build this program or this container locally, type make build. This will build the container image. So this app is now ready for us to test, debug. Type make test to run the usability or functionality test. As I have expected, all these tests has passed. Make security test. This test will test the security bug for the challenge. And in this case, I expect that to fail. Before I dive into the fix this security bug, another command that I can do anytime that you make a change to this program. Let's say I have opened the main program, main file. Anytime you save it to run the tests, you run make test. This will automatically build and then test the usability in this case, or make security test will do the similar thing. It will first check if you have the latest image built, and then it will run the test. A quicker way of doing it is to run make debug. This will get a shell from a container, and now inside this shell I can run those test commands. For example, in this case I can run pytest, and this will test both usability and security test that is being given to us inside the source directory. And anytime I change anything here, let's say I remove this print statement here, these changes are automatically applied within this file inside the container without the need to rebuild the image. Effectively, it's volume map the source directory to the container. This will speed up the whole debugging process for us. Now let me exit this shell. Another command is called make push. This will git add, git commit, and git push the changes to the remote repository. You can either run make push, or you can just manually type in git add, git commit, and git push. An example of it has been given to you inside the readme.atalk, and here you can see what this command does. Now if you hit make push, this will push the code to the remote repository, and now the server testing will kick in. A final pro tip, make a status. This make a status will fetch the result of the test output from the server. These are the tests. This is the test output from the server, and you can see it in your terminal without switching to the browser. So in this case, I can see the remaining time, the status of the test, and the output of that. One thing, always remember, this page, the commit or the challenge page, must remain open. Otherwise, server test will not kick in anytime you push your changes. Now, with all that, let's just dive into the program itself. Now, this program, let me get rid of these comments here. As we can see, similar to our previous guide, it just on root, it will return hello, following with the query parameter, whatever it gets in the URL address bar as a GET request. So it looks for variable query parameter name, and it will return that. Now, looking at the usability test, this is same as before. Now, the second test has changed slightly. It will get a query string name with the value Alice, and expect that the program has the Alice in the response. Now let's just run and test it. Make run will run the program locally in your system, and here is a web application. It opens the port 8080 locally on my machine. So I can open a new terminal and use curl to communicate with the program, or even I can type localhost port 8080 here for the same effect. Now, if I provide a query parameter name, I expect to see that. Now, this is a time that you want to play around and think about, okay, what could possibly go wrong with this program? It's a common and a trivial security bug right here. Anything that I type in or anything that I provide in a program in a query parameter is being effectively echoed back. Now, as a normal user, we may just enter names and numbers, but as an adversary, he or she may enter something like this. And that JavaScript code alert 1 got executed under the context of the HTML. Without going further detail about there's so much detail, this is an example of cross-site scripting or reflected cross-site scripting that happens here. An attacker or an adversary can provide an arbitrary JavaScript function, give this link to the users of this system, and that arbitrary JavaScript will get executed. And using JavaScript, you can do quite a lot of things to that user. One of them being you can potentially exfiltrate their cookie sessions. So this is not good, and the program does not behave as expected. If we look at the security test, this security test effectively tests for that. Instead of Alice, here we have the script tag. But one way to prevent for cross-site scripting is to escape these dangerous HTML characters. And this is what we can see on line 9, that the security text expects the program to return. And hence, when we run the security test, it will fail because the program will not return the expected escaped characters. For example, escape character less than for this. So to fix this, there are a number of ways we can do. We can write a simple mapping algorithm to map these values with the escape equivalence, or in this case, Flask, which we are using Flask framework. There is a helper function called escape. Very simple. It converts the characters such as that to the HTML safe sequence. So effectively those values you see in the test. So we can go back to the main code and import that function. Again, we can only import from existing libraries, whatever been given to us, in this case from the requirement file. We cannot install new libraries to pass the challenges. Escape, and I just need to call this function here. And that should be it. If I run make security test now, I expect this test to pass. Also, I need to make sure I have not broken the program. Make test, that also run. Let's just also rerun the program. And I think I had the program running here. Just stop this, make run, just to make sure if anything that I have done has not broken the program. Well, it seems like it's been working well. Now it's a time for me to make push. And this will run the usability test before it pushes the changes, and I can just keep running make a status. The test status of a challenge is running, and make a status again. And as I can see, scroll up, status passed, and all this pass has all done. If I go to the main page, I can also see test has been passed, and I have managed to fix this security issue. I can also run this challenge without the container. To do so, well, what I need to do is effectively go inside the source directory. This is where all the code is, and open up the IDE, and effectively firstly install these dependencies. Now in the case of Python, we need pip command .text, and following with, well, any other Python command, and to run test the program. One final thing before I finish up, the example security patch that I have discussed here, firstly, is known as output encoding. Is a technique that is use to prevent cross-site scripting. There are other techniques that we can use to prevent it. This is one of those. However, I should also mention that this patch is not recommended for enterprise programs, and because there are other ways that we can build a more robust way, especially when we have a larger code base that I have not discussed here, just for the sake of the challenge.